Good evening, students. Today we are going to continue with the second part of coordination compounds. That is, we'll discuss about the ligands. In the first lecture we have discussed about monodentate. Now let us talk about didentate ligands. You remember what is meant by a ligand? A ligand is nothing but which donates lone pair of electrons. Didentate represents here there are two donor atoms. And they will form two coordinate bonds. So let us see some examples which contains two donor atoms here. First one, oxalato. We can write it as OX. So OX represents oxalato, which is didentate. To get the structure, let us write oxalic acid first. So we know the formula of oxalic acid. From this, let us remove H plus ions. So we get COO minus and COO minus. So here we are having oxygen as well as another oxygen as donor atoms, two donor atoms, hence we call it as didentate. So oxalato, this can also be written like this. If you combine C2O4 2 minus. If you expand, this will be the structure. If you want to write condensed formula, you can write C2O4 2 minus. Second one is glycino, can be represented as GLY. First write glycine, because it is amino acid, you have to write amino group, N with the lone pair, acid COOH, and this is H. So here we have to represent R. So if you consider glycine, R is nothing but hydrogen, hence we write the structure of glycine like this. In this amino acid, again you remove H plus. Then what we get? CH2 as such. Here you have NH2, nitrogen with one lone pair, and COO minus. So we have two donor atoms, one is nitrogen, another one is oxygen. Hence you call this glycino as didentate ligand. Third one, dimethyl glyaximeto. We can write it as a DMG. So the short form is DMG. Now what will be the structure of this? First write two carbons, dimethyl, hence write CH3 groups. So dimethyl. Next, double bond N and double bond N with the lone pair. Here mention OH, here write O minus. So we can have nitrogen and oxygen as the donor atom, hence DMG is also didentate. Next, fourth one, ethylene diamine. We can write it as EN. So EN represents ethylene diamine. So first if you write ethylene, CH2, double bond CH2, now that pi bond has moved to adjacent position, and here you have amino group, that is NH2 here, the other side NH2. What are the two donor atoms? This nitrogen as well as this nitrogen. Hence we can say that it is didentate ligand. Next, the last one, dipyridyl, you take represented as DIPY. So in this we know that two pyridine groups. This is one pyridine, N with the lone pair, and again second ring of pyridine, N with the lone pair. So here we have again two donor atom, hence dipyridyl group can be considered as a didentate ligand. Hope you have understood this. Any ligand which contains two donor atoms can be called as didentate ligand, and we have discussed 5 examples. Next, let's move to tri, tetra, penta and hexadentate ligands. Next type of ligand, that is tridentate. Tri represents 3 donor atoms. So in this ligand we have 3 donor atoms and they can form 3 coordinate bonds. If you are checking the examples, first one you take it as diethylene triamine. Okay, we can write it as DIEN. So first example, diethylene triamine. First write two ethylene groups, CH2, CH2, leaving a gap, CH2, CH2. Now how many amine groups are there? 3 amine groups. Hence we can write NH here, one lone pair. The other side, one amino group, and here the third amino group. So hope you have understood this. We have diethylene and triamine. Here what are the 3 donor atoms? First nitrogen, this is second, and this one is the third donor atom. Hope you have understood this example. Second one is aspartate. So we can write it as ASP. Before writing this ligand structure, let us write aspartic acid. You know that amino acid contains COOH group and amino group. So here H. Now what will be your R group? Because it is aspartic acid, 2 acidic groups. In the structure we know it is CH2COOH. So this is your R group. So we have written CH2COOH as R group here. Now if you remove H plus ions, what you get here? This is minus, and here you have one lone pair. So therefore this will get converted into aspartate ion, that is nothing but COO minus CH2, and here H as such, NH2 and COO minus. Hope you are able to understand this. So what are the 3 donor atoms? In the aspartate ion we have nitrogen, oxygen, and another oxygen. Hence we have 3 donor atoms. Hence we call this as tridentate ligand. Hope you have understood the examples and how to write the structure. Next let us move to tetradentate. Now the next type of ligand, tetradentate ligand. Tetra represents 4 here. So any ligand which will have 4 donor atoms is known as tetradentate ligand. Let us take the example triethylene tetramine. So we can write it as tri-EN. So the example is triethylene tetramine. How to draw the structure? First take 3 ethylene groups, CH2, CH2, we can take 3. After this we have to represent 4 amine groups. Let us write amino groups here. Here lone pairs, as well as on the other side NH2, here again NH2. Hope you have understood this. We have taken 3 ethylene groups, and to that add the amino groups here. So triethylene tetramine, here we have 1, 2, 3, 4 nitrogens here. Hence you call it as tetradentate ligand. So 4 donor atoms, tetradentate. Next one, pentadentate. So pentadentate ligand has got 5 donor atoms, so that it can form 5 coordinate bonds. Let us take the example ethylene diamine triacetate. So this is the name of the ligand, ethylene diamine triacetate. You know ethylene CH2, CH2. To that we have to represent 2 amino groups. So NH2 and NH2. Now the next one is acetate of group. You know acetate of CH2COO minus, and how many groups are there? 3 groups. To form that, first let us remove 2 hydrogens here and write CH2COO minus, and by the substitution of second hydrogen again write CH2COO minus. Now the last one, let us remove 1 hydrogen, and there we can have CH2COO minus. So here what are the donor atoms? oxygen, second, third, fourth and fifth. So 2 nitrogens as well as 3 oxygens. Totally we have 5 donor atoms, hence we call it as pentadentate ligand. So first write ethylene, then complete with the amino groups. After that substitute 3 hydrogens with acetate groups. So this will be your structure, and the example is called as pentadentate ligand. Now the last one, let us see hexadentate ligand. Now the last type of ligand, that is hexadentate ligand. Hexa represent 6 donor atoms to form 6 coordinate bonds. So here, what is the example for hexadentate ligand? We write it as EDTA, ethylene diamine, tetraacetate. So EDTA nothing but ethylene diamine tetraacetate. Sometimes they call it as tetraacetate also. First and foremost thing, write ethylene group CH2CH2. Next diamine NH2 and NH2. Next to write 4 acetate groups, we need to remove all the 4 hydrogens. So here we can remove hydrogens. Now substituting the hydrogens with acetate group CH2 COO minus, and on the other side also we can substitute with acetate groups CH2 COO minus. Hope you have understood this. First we have taken ethylene, next diamine NH2 groups on both the sides. After that remove 2 hydrogens here and substitute with acetate group. Here also remove 2 hydrogens and write acetate group. So here we got how many donor atoms? 6. So 2 oxygens here, 2 nitrogens, 4 and 2 oxygens. Totally we have 6 donor atoms to form 6 coordinate bonds, hence you call it as hexadentate ligand. Now let us see the nomenclature. So how do you write nomenclature for coordinate complexes? In the previous class we have discussed that there are 3 types. First one is MLX0. M is metal atom or ion, L is ligand, X is number of ligands, and this will be neutral. So first one is, we have neutral coordination compounds. Second one, MLX plus, nothing but cationic complex. Third one, MLX minus, here it will be anionic complex. Now to write the names, there is a simple formula. For these two we have similar type. What is that? We will write it as number plus name of ligand. First and foremost thing, how many number of ligands are there, then name of the ligand. After that, write the name of the metal. This will be written in English. To that, oxidation state is written in bracket and write in the Roman form. Hope you have understood this. Number plus name of ligand, metal in English plus oxidation state in Roman number. Now for this cation, everything remains the same. Number plus name of ligand and metal in the English form plus oxidation state in bracket in the form of Roman numeral, and at the end only one difference, we need to write it as ion. So this will have no space, continuously we should write this. Hope you are able to understand. Now for the third one, that is anionic complex, number plus name of ligand, then comes metal, but here we will take in the Latin form. We are not taking the English form, we are taking Latin. For example, if you take Fe, here you will write it as iron, and here you will be writing as ferrum plus 8, metal plus 8. So terminal thing we have to write 8, ferrate plus oxidation state in Roman number, and at the end we have to mention ion. Hope you have understood the difference. These two remain the same. At the terminal position, ion should be written, And for anion, we have to mention Latin plus 8, and at the end we have ion. If you remember this formula, writing the names for the coordination complexes will be easy. So make a note of this and let's move with the examples. Now let us see the nomenclature of cationic complex. I have taken one example like this, like CuNH3,4SO4. So they can give in this form or they can give only cationic complex. So first let us solve this. Sulfate, the charge is 2 minus, therefore here we can get plus 2. So the same thing I have written. If it is given completely, both cation as well as anion, how to write, as well as if they give only cation, how to write, we will see. Now, what is the formula? Number plus name of ligand. How many number of ligands are there? 4. Therefore, tetra. We should not have any space here. Continuously we should write starting with the small letter. Now, NH3 is AMMINE. So this is number, this is name of the ligand. After this metal. Metal is nothing but if it is cation, you have to take in the English name. So that is Cu. Therefore, I will write copper. So this is in the English name. After that, we need to write oxidation state. How to calculate oxidation state? This is 0. So NH3 is a neutral ligand, hence 0. So total is plus 2, hence here also you will get plus 2. If you want to solve this, I will write like this. X, this is X plus 0 is equal to plus 2. Therefore, X is equal to plus 2. This way you can write, otherwise directly you can calculate. So here also 0 and plus 2. Now what we need to write? The bracket we will take it as Roman number 2. Why we wrote Roman number 2? Because oxidation state of metal here is plus 2. And at the end we need to write ion, if at all it is given like this. But because they have given anion also, therefore we will leave some space and write it as sulfate. So this will be your name of this particular coordination compound. But if they give only complex, what we write? We write number, tetra, name, same thing, amine. After that, don't leave space, copper, Roman number 2, and write as ion. Hope you have understood the difference. See, if they give like this, we write sulfate by leaving the space. Always cation should be written first and anion next. Now let us see, from now onwards we will see only the complex. Here what is the ligand here? Nothing but H2O. We have 1, so we can write it as number is 1. So if you want, you can change this also. We can take it as 6 here. So hexa, H2O is written as aqua. So hexa aqua, and this one you take it as X and calculate. X plus 0 is equal to plus 3. Therefore, X is equal to plus 3. Therefore, oxidation state here will become plus 3. Hope you have understood this. First number, hexa, then name, aqua. After this, because it is cationic complex, you have to write the metal name in English. Nothing but iron. And Roman number 3, ion. So this will be the name of this cationic complex. Now let's move to the other examples. Now if you take cationic complex here, Cl is minus 1. Therefore, we have minus 3. Here it will be plus 3. So the cationic complex in which NH3 is neutral, this will be taken as X. We can calculate X plus 0 is equal to plus 3. Therefore, X is equal to plus 3. So CO will have oxidation state of plus 3. Now we have both positive as well as negative charge, hence we don't write it as ion. Now the number, how many we have? 6. Therefore, hexa. NH3 is written as amine. So number, name of the ligand. Now because it is cationic complex, metal should be written in English. Therefore, CO, cobalt. After that, As oxidation state we have calculated right in the Roman number, that is cobalt oxidation state is +3. See, if at all they give only this cationic complex, we will write ion, but here it is been completed with the negative charge, therefore leave some space and write it as chloride. Hope you have understood this. If this is only given like CO, NH3 6 and 3 plus, so what we write? We write hexa amine cobalt Roman number 3 ion. Hope you have understood the difference. If they give only cationic complex, we have to end with ion. If they have given us the spectator ions or counter ions Cl minus, therefore we write it as chloride. Now let us see the next one, that is with the negative charge anionic complex. Second type, that is anionic complex MLX minus. We know the formula number, name of ligand, and here metal will be in Latin. And suffix ATE we have to write oxidation state in Roman number and ion. So this will be our formula. Now first one is COCN63 minus. This is anionic complex. Cn we have -1. This is X. If you want to solve, we can write X minus 6 is equal to -3. Send this to other side, we have X is equal to +3. So oxidation state we have calculated, that is cobalt will have +3 oxidation state. Now applying the formula, first write number, 6 ligands, therefore hexa. Don't have any space here. Next, the name is cyanido, so hexacyanido, number, name of the ligand. After this, metal is nothing but cobalt, and we have to write ATE. Earlier we used to write only cobalt, now we have to write ATE. Both in Latin as well as English it is same, so cobalt. Cobaltate, Roman number 3, and here there is no positive ion given, hence we can write it as ion. Hope you have understood this. And now here it is +1, total charge here is +3, hence this will become -3. So anionic complex. Cyanide -1, this is X. We can calculate X minus 6 is equal to -3. Hope you are able to understand. To find oxidation state, I have taken X. This is -1 into 6, -6. Total is -3. Send this to other side, we get X is equal to +3. Therefore, oxidation state of Fe is +3. Now, we have both positive as well as negative here. Therefore, we can write first cation, that is potassium ions. Leave the space and then follow the formula. How many ligands? 6. Therefore, hexa. Here we have to leave a space indicating this is cation as well as anion. So, hexacyanido. Name also we have written. After this, Fe is English, we have iron, but here we have to write ferrum +8. It will become ferrate. Oxidation state is +3, hence in bracket we have written 3. There is no need to write ion because we have positive as well as negative charges here. If at all we have only the complex of anion, then we can remove this and write at the end ion. Next one, here Na+1, and if you take total charge of this is +3, therefore it will become -3. NO2, nothing but nitro, -1. So here oxidation state, consider it as X. So for cobalt you have to calculate the oxidation state. Now X -1 into 6, -6. Total charge is -3. Send 6 to other side, -6 now will become +6. Therefore, oxidation state on cobalt will be +3. So now, once again you can understand that both positive as well as negative charges, therefore we will write cation first. So this is nothing but sodium, so write sodium. So Na plus we have written sodium, the cation is written first. After that, now number 6, therefore hexa, don't leave any space, write NO2 is nitro, hexanitro, after that metal, cobalt and ATE. So we have cobaltate. Next, Roman number 3 to represent oxidation state. Hope you have understood this. Number, name of the ligand, metal plus 8 and oxidation state in Roman number. Hope you have got this. Next, Na plus 1. This will become minus 3 because total positive charge is plus 3. Here it will be minus 3. Now Fe is minus 1. Take Al is X. X minus 6 is equal to minus 3. Minus 1 into 6, minus 6. Send minus 6 to other side. Therefore, oxidation state of Al will become plus 3. Next. See, we have both plus and minus. Therefore, write the cation first. So we have sodium. And to this anionic complex, you apply the same formula. Number 6 ligands. Therefore, hexa. F can be written as fluorido. After this, don't leave space. We have to write metal plus ATE. So it will become aluminate. And Roman number 3 representing the oxidation state. Hope you have understood this. If they give only this, remove this and write at the end ion. So this will be a simple formula to write the nomenclature for the anionic complexes. Now the last one, we can see examples of neutral ligands. Now the last one, that is third type, MLX to the power 0, that is neutral complexes. Now here the formula is number plus name of ligand, metal in English, plus oxidation state in bracket. So we have to represent a Roman number. No ion should be written because it is neutral complex. So everything we know. Now let us take two examples, we can understand this. First one, number 4, therefore write tetra. CO is nothing but carbonyl group. So name is carbonyl. After that metal is Ni. You know that the oxidation state, if you consider, it will be 0. So hence tetracarbonyl nickel in English, and write in the bracket 0. So this will be the neutral complex name. Next one, the number 5, therefore penta. Name is carbonyl. So pentacarbonyl. Here Fe, English name, we have to write it as iron, and 0. So this will be the method of writing, that is neutral complexes. So nomenclature of neutral complexes we can write like this. Hope you have understood the difference. If you take MLX 0, you have to write number, name of ligand plus metal in English, and oxidation state in Roman number in bracket. If it is cation, that is plus. Only one change here. At the end you will write ion. Hope you are understanding the difference. Suppose if you write minus, that is anionic complex, here you have to take metal in Latin plus ATE plus oxidation state in bracket Roman number, and finally write it as ion. So this way we can write the nomenclature for the 3 types of, that is, complexes. Hope you have understood this. Now in this lecture we have completed the types of ligands as well as how to write the names for the complexes. Hope you have understood this. Make a note of this. The next lecture will move with the isomerism. Thank you so much.